Hello everyone, welcome to today's episode. This is going to be video one of a three-part video series where we're going to be talking about how you can convert your native Android app built with Kotlin to work on the web using Kotlin Wasm. We're going to use Jetpack Compose for UI development, and in this case, for us to translate it to the web, we're going to use Compose Multiplatform for that matter. We're also going to use Kotlin Wasm, which is going to be the underlying technology that will build our web application from our Android native source code. Of course, we're expected to change a few things here and there. It's not going to be all smooth, all rides. There are some libraries that will not work for both Android and the web, and we'll have to look at ways in which you're going to circumvent that. Lastly, in this series, we're also going to check how can we adapt to different scenarios and device/platform differences. For example, on the web, you have things like the mouse and the keyboard being readily available. On the other hand, on your mobile device, you do have the keyboard, but you don't necessarily always have the mouse. You might need to work with your touch input. So we're going to discuss the different platform differences and what you're going to do in order to make up for each of them when we're trying to make our app run across the web and Android at the same time. Now, I have provided a simple project, which is linked in the video description. This project contains very, very basic things. So let's have a look at what it looks like. I'll run it. There's a simple page that allows us to set our nickname before joining in. It's a random recipes generator app. So we basically will look for different random recipes from different categories across the web on our URL that I will provide in the link below. I'm using the MailDB, which has been one of my go-tos, one of my favorites. So I think you can try it as well. So let's try and provide a name here. Very, very simple one. Let's say talent, maybe. Let's open that. You'll see this will contain a very small window. And this window just has a welcome message at the top and then some random meals from a specific category. Not sure which one this is. This looks like some lamb category. Yeah, lamb and potato pie, lamb and lemon. We could randomize this. Probably have, something else. This looks like some Italian. We can then randomize this. It's another set of Italian. Different things at different times that you can have when you're running this application. So you can also open a single item just to see what's going in there. So for example, this 15-minute chicken and halloumi burger, it has the different steps in there all the way to the end. So that's some good stuff to look at. Can go to something else, again, see how the instruction sets have been prepared. So something very simple and basic. We're just going to look at the process. How do we make design decisions? How do we make decisions on how we're going to use different APIs? Because sometimes there'll be an API that's not available for the web, but is available on Android. So how do we navigate such kinds of instances? Awesome stuff. There are a few things that we're going to do within this three-part video series. And today we're going to see how we're going to convert, number one, the build structure of our native Android app from a single module Android application into a single module Compose Multiplatform application. And to do this, we'll have to change a few things in our Gradle files. We'll also have to change the folder structure because our source sets will change accordingly. Also, the .id and .kotlin folders all just contain metadata, and so we're not really going to focus any time on them. The app folder is the module for our Android application, and that's where we're going to spend a good amount of our time. The Gradle folder will contain Gradle configurations. This we already know. In here, it also has our libs, our version catalog, which contains our library versions, and basically all our dependencies are managed to this file. And then .gitignore for your ignored Git files. Other Gradle configuration files are also there. Build.gradle, Gradle properties, Gradle wrapper, the batch file version of that, local.properties, and the settings.gradle.kts file. So those are the few things you'd expect to see in this project. Now, we're going to start off today's session, which will specifically be converting of the application to be a Kotlin multi-platform application, and more specifically, a Compose multi-platform application. What we're going to do is we will start by creating a folder, and this folder will contain our source sets. This folder will contain our source sets. To do this, the first thing we'll do is we will add a new subfolder, and this subfolder or directory I am going to call Compose App. Next thing, in our Compose App subdirectory, since it will be almost like a module in itself, it will need a build.gradle.kts file. You can add other things, say for instance your gitignore. Since it contains an Android application, you can also add your ProGuard rules for minification, similar to what we have in the other app folder. So for now, let us add just a single file, which we will call build.gradle.kts. So that's the first thing. So we're going to just add this empty file. Leave it as it is for now. You don't really need to make any sort of changes at this time. We're simply focused on the folder structure. The next thing we're going to do is we're going to add a subfolder, and this subfolder is going to be called source. Inside the first subfolder, we want to make a subdirectory, and we will add the first source sets. So we expect our application to run on Android, and therefore we will add Android main as a source set. Android main will contain all the functionality for the Android application. So anything that is Android specific and its implementation in Android will go into the Android main source set. There is another source set that we can add, since we expect this to run on the web. We also will need a source set for the web. In this case, our application will run on the web using WebAssembly. And since it will use WebAssembly, we need to add a Wasm main source set. One thing to remember though, Wasm can be used for practically any platform. It's not necessarily that we are stuck to a specific type of implementation with Wasm. However, for this project itself, since we want the application to run on the browser, we'll use Wasm.js main source set. This will be what will contain all our source code that will be specific to running on the web. So I'll add a source set called Wasm.js main. The next thing that I want to add is that since we would require to run some tests for our application, we can also add test files for Android specific code, and this will be under the package Android test. Another source set we may be interested in. Now, these are two different platforms, Android main and Android main and Wasm. However, sometimes you will have code that is shared between the two, which is the main idea of having a multi-platform application, whereby you can write code once and it will build on multiple platforms without you having to stress about very many things. So we will need to add the common source sets. We'll start with common main, and then we'll also add common test. Common main will add the main part of the code. Common test will have test files for your common main source set. With this 5, we could also add our Wasm.js test in case we want to implement something in that regard. So we can also add the Wasm.js test. For this specific video, we are only going to focus our energy on Android main, Android test, common main, common test. First target for this video is to make the app to run as smoothly as it was with the previous structure, with just having Android test, main, and test. We can see initially the source sets were 3, Android test, main, and test. Now, in a rough translation, Android test will map directly to Android test in Compose app. Main will map directly to Android main in Compose app. And then test will map to common test in Compose app. Now, there are some things that will be in main from the app source set and might not necessarily always go to Android main. There'll be some things we will share into common main. For example, how the UI is structured and how the navigation will work are platform independent. This can use a single framework, and that will go into common main. However, there will be some source code that will only be specific to Android, and we'll have a look at that later. For today's video though, we just want to make sure everything will work within the Compose app structure. And the Compose app structure in our scenario here is our Compose Multiplatform project. Now we are safe to delete the temp file, We're safe to delete the .temp file and continue with other pieces of things. Now, it is important to know that within a native Android project, a lot of things will always come by default within the project when you create it using Android Studio or IntelliJ IDEA. However, with Compose Multiplatform, right now outside of the wizard, you may need to do a lot of things manually. We will need now to configure how our build files will work with our project structure to make this Compose application file work. So first thing you'll do is you'll add Compose app into your settings.gradle.kts file. The next thing we will do is we'll head over into our Gradle version catalog. We'll go into our Gradle version catalog. And within here, there are a few things that we want to consider. Right now, we have 4 plugins within this existing application: the Android application plugin, Kotlin Android plugin, Kotlin Compose plugin, and Kotlin serialization plugin. All those well needed. There are 2 more plugins that you will need in order for us to complete this. The first one will be the Kotlin Multiplatform plugin. We will also need the JetBrains Compose plugin. We'll need Compose from JetBrains. This is the Compose Multiplatform plugin. We'll add that. It is important to also note that we need to specify our Compose version. Now, currently, in my existing project, we are using the Compose BOM. Therefore, we need to add the Compose plugin version for this to work. I will use 1.7.1 for now. Yeah, let's use 1.7.1 for now. Not sure which is the latest plugin version, but this is a pretty stable one as of the time of the making of this video. Once you add those two in, it is advisable that you run your build. Now, since we are yet to set up a few things in the Compose app subdirectory, let me first remove this, then resync our project. Once that happens, we can go into our build.gradle.kts file that is in the root directory. From here, we're going to add our two libraries, the two plugins that we've added. So plugins.kotlin.multiplatform. And then we also want to use the JetBrains Compose. So plugins.compose.multiplatform, and we'll make applying of that to false. We'll also need to go into our submodule, but since our submodule for now does not have any code, we'll leave that as it is blank. So we'll run this to import our newly set libraries now. The next thing we're going to do is we're going to build out our Compose app Gradle script. So open that script. We're going to add the plugin section as the next thing. Within the plugin section, we're going to import a good portion of what we had in this other plugin section. So let's just copy those, apply, do not have them as true, I do not have them as false, have them as just true. It's important that your Kotlin multi-platform plugin should be the first one to be applied. The order of the others doesn't really matter. However, we need our multi-platform plugin to be the very, very first one. The next thing we'll need to put in play is we should be able to set up at least one target. We should be able to set up at least one target on our project. To do so, we'll need Kotlin bracket and then call the Android target. Within this Android target, we'll use something called compiler options to set the JVM target. So we'll have our compiler options, of which we will set our JVM target, and we will set it to something in the region of JVM target dot JVM 17. I'm using I have JDK 17, so we're gonna do that. Now, it's also important to note that your compiler options is something that you need to opt into. So we will opt in to experimental, Kotlin Gradle API. and this needs us to import this. So this is coming from JetBrains, the Kotlin, the Gradle dot experimental Gradle API. So I'll just copy this, have this in here. So it needs us to opt into this. The next thing that we are required to do is to have a source sets section. But for now, let's try and get this to build first. So let's just rebuild the project. So we are being told that, okay, so this project has not been loaded. So we'll go back to our settings.gradle file, and we will also include compose app. So if we run this, I do expect us to run into some issue, which is fine. Finished with some failures. So we are being told that there's a missing Android Kotlin target in multi-platform project compose app. So registering the Android target, which we have done, we will need to also add the JVM target, I feel. This needs to be imported. So let's again go into org.jetbrains, and this is inside Kotlin, Gradle. This is actually experimental with this lowercase x. That might be one of the things that we had an issue with. But this one is Kotlin DSL, JVM target. So let's try this. Okay, so we have a different issue. Still the same one. Within here, we'll add primarily Android main, the dependencies, and then we'll also have Android test, the dependencies. Yeah, we'll have those two first. And then we also need to set up our Android plugin. So let's go to our app, build.gradle.kts. So this is not very difficult to do. The first thing you'll need to have is we can just copy out this entire Android block from within our app, build.gradle.kts. So we can copy this entirety, come back in here, add it, but there will be some few things we will have to kind of change. Now, having a namespace, compile SDK, all these are actually okay to use. The only thing that we might need to change a bit is, firstly, we'll need to provide a link to where our manifest file is. So I know right now we do not have a manifest file, but we will add it. So we'll just say source sets, and we want to specifically set the main source set. So since in our app module main, that's where the Android manifest goes, and that's where the Android OS will recognize it from, we need to also put it in a similar place. So source set main, and then the manifest file will be inside source Android main Android manifest.xml. So we'll put our file here. Outside of this, our Gradle file is almost complete. And what makes it complete is we need to put in our dependencies. So put in our implementation, copy that. Let's bring that back. So all this go into Android main, and then we'll have our Android test. So all this will also go into Android test. So since we are in a Kotlin multi-platform project, we cannot really just use Android test implementation. We'll need to use basically just implementation because it's already inside our Android test source set. So those are generally okay, but there are some other things that we need to do. Inside Android main, we'll need to add our manifest file. So we're going to file, and we're going to say Android manifest.xml. So that's where it's going to go. And in our Android manifest, I will just copy out everything that is inside here, put it here. Another thing that we will do will be adding a subfolder. So the first subfolder that we're going to add is called resources. First subfolder will be called resources. Second subfolder will be called Kotlin. Second subfolder will be called Kotlin, and Kotlin will have a package. But before we add the packages, I would like to see whether we can get this to run as it is. So it still indicates a missing target. The issue that we're currently having after a bit of time just looking into it is because we do have two things defined here that are not supposed to be the same. So the Kotlin multi-platform target as a plugin and the Android plugin cannot both go in the same place. So we'll have to get rid of the Android plugin. That can only go into a module that supports Android specific things only. Another thing we need to take note of is that we don't have an Android test source set. It's actually Android instrumented test source set. Also, once we do that, we need to set our JVM options inside our Android target, which we've already done. And therefore, we need to remove our JVM target inside Kotlin options from our Android Gradle section. This should now work as smoothly as it should, but there's one last thing. Now, platform is not supported in Kotlin multi-platform anymore, or rather it's been deprecated and will be removed after 2.1. So we'll replace it with project.dependencies.platform. Project.dependencies.platform. And then last thing we'll also need to have, just for this to work straight out of the box, is Android unit tests. Android unit tests. And with Android unit tests, we are going to also carry along a lot of the build configuration things. So should be these two, JUnit and mock. JUnit and mock. And again, remember, test implementation is not allowed here. We are going to use implementation. Now, this looks like a well figured out Gradle file. So we'll rebuild this, and now it builds successfully. So we've been able to set up the Gradle structure for our application. We'll need to change just a few things because if you remember in our project section, we had Android main, Android test, common main, common test, which actually will work just fine. This will work just fine. I wanted us to change Android test into Android instrumented test, but this will still work the same. This will still work the same. So that's okay. That will work. Now, we want to continue moving bits and portions of our project. And the next thing we will move is, of course, inside our Android main, we want to move all our resources. So let's start by highlighting out every single portion of our resources, drawable, map values, and XML. Copy those and have those moved to resources. So you'll be asked whether to put them in a Git. So that's a choice that you have to make for yourself. We are also required to move everything into our Java subpackage into the Kotlin subpackage. So I will move the entire package and then I will add them there. So there we go. This needs to be in a package com dot, because the other one just moves the final folder as opposed to, so there was an IDE crash report. We'll check that out later, but for now, just want to be sure. Yeah, so when those moved, we can delete this subfolder that is not necessary. Great. So now we have our source code go into the Kotlin folder. Next thing is we will need to move things into our test folder. So we're going to move them into our test folder. So everything in Android test. We're just going to move this. So we'll first create our package. So this will be Kotlin package, Kotlin folder or Kotlin directory, but then I'll add my package name. con.tobishi.random recipes. Awesome stuff. So we just move whatever we had in here. So let's just move that test. So I wrote only one test just to show how things will work. So we can, send those there. To factor anyway. Yeah, so this will work. I'll just need to import the details that are now probably in a different route. So yeah, that's fine. Great. The other thing that we might be wanting to do is we want to also put all these unit tests somewhere. So we're going to add a source set for Android unit tests for now. So we're going to look for Android unit tests. So this is the one that we will add. It's a Kotlin source set. So Android unit test. And we are going to just move everything. Again, similar to what we had before. Add a package. And then inside the package, repository test. Let's just change that quickly. And actually, just import this. Great. So we've moved our Android main, Android test, and Android unit tests all into the Compose app subdirectory. With that done, the last thing we'll need to do is probably move our ProGuide rules.pro for when we are packaging our app. This will contain our minification rules if you have any. I'll move mine, which is currently just empty, into Compose app. And that, as it is enough. So what we will do is we will just synchronize Gradle. So we're going to build and then just rebuild project. Rebuild project. Let's see how that will go. Fantastic. The rebuild has happened successfully. Now, the only thing left to do is to check, is our current folder structure working as it should? So we go into random recipes, and then we want to run the one from Compose app. So firstly, let me just go in here, and I'd like for us to uninstall this app for now. So this is not the one. I do have very many, so it's this one. No, so it's that one actually. So let's go here and just uninstall this app. So that works, and then we rerun this, and it force closes. So let's find out what's happening here. What is really happening here? Okay, now there is something that is important to note, right? We are being told that the reason for this crash is because the serializer for this is not been found. Either the class is marked as serializable or the compiler plugin has not been applied. So surprise, surprise, it is the compiler plugin that has not been applied. And so let's see whether we have it first in our Gradle. So we do have the serialization plugin. We could just copy the implementation of the serialization plugin here, copy that, and we go back to Compose app and make sure we have the serialization plugin. So re-import and rerun, and that works perfectly. So we say plugin data, we go in and you can see our app runs the same way as previously. So that's good. That's good. We've been able to make our app run fully from a Compose multi-platform app perspective. I will copy over the git ignore because it will also be necessary. Git ignore just for our excluded files. And lastly, the last thing we need to do now is, since we have shifted from using our native app module, we can now safely delete it. So before deleting, I'd like to first remove it from the project there, synchronize that, and then it will be a plain folder which you can now just delete that, and you can rerun Gradle, and lastly you can run again the app, and you can see the hello world is logged in. So some fish, etc. Great stuff. Now, it is important to note there are a few things we've been able to do today. Number one, we've been able to understand the structure of the currently existing application. Secondly, we've been able to move our Android application as a whole, as it is, into a Compose multi-platform project. Right now, all the code is running from the Android source sets. There's nothing different that we've done either to add multi-platform capabilities or anything. It's just the project structure that is in multi-platform. In our next video, we are going to start transferring components from the Android app into a multi-platform project. With this, we'll be able to see, one, how are we able to run the application itself on the web? What do we need to change for it to stop working as just an Android app and also working as a web application? Because right now, as it is, we do not have anything that configures the web for us. We have only done Android configuration, and it's still the native Android app that is running. Watch out for the second part of this video, where we'll be talking about the remaining of the steps to make it work on the web. I hope you enjoyed this one. Keep it locked in, stay tuned, and as always, subscribe